In thermal properties of matter, what about linear expansion? In the previous videos we explained what is the thermal expansion and types of thermal expansion. One of them is linear expansion. So linear means along the length. So expansion along the length of a body on increasing temperature, on heating the body, is called linear expansion. So what about the linear expansion? Consider we have taken a metal rod. Its length is L1 at the temperature T1 degree Celsius. Now its temperature is increased to T2 degree Celsius, then length of the rod increases. So now the increased length of the rod is L2. Now what is the change in length? It is delta L. It is the original length at the temperature T1 degree Celsius. At the temperature T2 degree Celsius, so changed length L2. Now, so what is the change in length of the solid from here to here? This is denoted by delta L. So here change in temperature is denoted by delta T, which is T2 minus T1, that is final temperature minus initial temperature. So change in length of the solid rod, that is metal rod, is L2 minus L1. But this change in length depends on temperature and also original length. When the original length is higher, change in the length delta L is also higher. When the original length is lower, change in length is also lower. It means that delta L is directly proportional to L1. It is equation 1. L1 means original length, delta L is change in the length, that is at the time after rising the temperature. This delta L also increases with the increase in change in temperature and decreases with a decrease in temperature. So it means that delta L is also directly proportional to delta T. It is equation number 2. So delta L is directly proportional to original length L1. Delta L is directly proportional to change in temperature. So now from equation 1 and 2, we can write delta L is directly proportional to L1 into delta T. So from equation 1 and 2, delta L is directly proportional to L1 and delta T. So now delta L equal to, eliminating a proportionality symbol. This is a proportionality symbol. We are writing a constant alpha L1 into delta T, where alpha is a proportionality constant, where alpha is a proportionality constant, called coefficient of linear expansion. Coefficient of linear expansion. So this is given by the formula alpha is equals to delta L by L1 into delta T. But you know delta L is equals to L2 minus L1. Final length minus original length. L1 into delta T means final temperature T2, initial temperature T1. We can also use this formula for calculating coefficient of linear expansion. But what is coefficient of linear expansion? So what is the coefficient of linear expansion? So this is a increase in length or change in length. It is the original length, it is a change in temperature. So the increase in length, per unit original length per unit original length. Per unit original length means here L1 per degree rise in temperature of the body is called coefficient of linear expansion. So it means that per unit original length on rising 1 degree Celsius temperature or 1 Kelvin temperature, what is the increase in length in the solid? So is called coefficient of linear expansion denoted by alpha. So alpha is equals to, now unit of alpha, SI, that is a unit of coefficient of linear expansion is degree Celsius inverse or Kelvin inverse. It is the unit of alpha. Alpha means coefficient of linear expansion.